Hi everyone, welcome to Java Wave, where we will discuss about Java interview questions and their answers. I am Gayatri, and today's interview question is difference between ArrayList and LinkedList, which is very famous interview question for beginners as well as 2 to 3 years of Java developer. Before getting into differences, let's try to understand similarities between ArrayList and LinkedList. Both ArrayList and LinkedList implement list interface. So they have got default behavior of list interface also. Due to that, both are ordered collection and they will maintain insertion order. Both will allow to insert null value and as well as different type of object. Both implement serializable and clonable interface. Both ArrayList and linked list are not synchronized collection and which can be synchronized via using collection.synchronizedList method. And iterator and list iterator methods for both are fail fast, which will throw concurrent modification exception, whereas fail safe will not throw that. So let's try to understand ArrayList first. ArrayList is growable array which has initial capacity of 10. Means initially maximum 10 element can be stored in ArrayList, and after reaching to its maximum capacity, new ArrayList will be created with increased capacity, and all the record from older ArrayList will be copied into new ArrayList, and older ArrayList will be eligible for garbage collection. And formula for new ArrayList capacity is terrain capacity into 1.5 plus 1. Initial capacity is 10 into 1.5, that is 15, plus 1, that is 16. So new capacity will be 16. 16 additional element can be stored. If I don't want to create array list with default initial capacity and I want to provide larger number as initial capacity only, that can also be done. And since ArrayList implements random access interface and it has index based data structure, it is good to use when elements are getting fetched frequently. Means if it is retrieved frequently, it just to use get method, provide index, it will fetch object from that index. ArrayList is not good to use for frequent addition and deletion of element due to multiple shift operation. Like if there is a array list of 100 element and I want to add any element at 50th position. So since there is already a element at 50th position, that need to be shifted at 51st position so that I can add element at 50th position. So just to add a element, there will be 50 shift operation. Similarly for delete operation also, if I want to delete any element from 50th position, after deletion 51st element need to be shifted at 50th position and there will be again 50 shift operation. So ArrayList is not good to use when there is frequent addition and deletion from middle of the collection. So we saw ArrayList. Let's try to understand linked list also. Linked list internally maintain doubly linked list which store memory address of previous and next object. So there will be node kind of structure which will store memory address of previous node and next node as well as actual data value also. And there is no initial capacity defined for linked list, which was case for array list. And since linked list is not implementing random access interface, and to fetch any element from linked list, it is need to be iterated over all the element. It is slow while fetching element. Means if any element is stored at 99th position, it will start from first node to get the element from 99th node. So it is slow while fetching element and it is not good option if there is frequent retrieval operation. But linked list is faster than array list while inserting and deleting element. For example, if I want to delete any element from 50th position, just 50th node will be taken out and 49th node will store memory address of 51st node and 51st node will store memory address of 49th node, as they need to maintain previous and next memory address. Same will be maintained in the case of addition also. So linked list is good option when there is frequent addition and deletion of element from middle of the collection. So finally, let's see difference between array list and linked list, which was our actual interview question for today's video. Array list is drawable array implementation, whereas linked list is doubly linked list implementation. Array list implement random access interface, whereas linked list does not implement this. Array list is good for fetching element from middle of collection, whereas linked list is good for adding and deleting element from middle of collection. Array list has initial capacity of 10 element which can be changed also, and there is no initial capacity defined for linked list. Array list consumes less memory than linked list as it stores only data of particular index, whereas linked list stores address of previous and next object and value of actual object also. That is the reason it consumes more memory than array list. So this was difference between array list and linked list. I will come with few more interview questions from relation framework only, where we will see difference between another relation objects. And to know about more interview question, please subscribe my channel Java Wave, where I used to come with new interview question every week. Thanks for watching. See you in next video. Hi everyone, welcome to Java Wave, where we will discuss about Java interview questions and their answers. I am Gayatri, and today's interview question is use of hash code and equals method in collection framework, which is commonly asked interview question for all level of Java programmers. So let's try to understand equals and hash code method. Equals and hash code method both are present in java.lang object class, which is super class for all the Java class. Means any object can use equals and hash code method of object class. So what equal method will do? It will compare both the object and it will return true if their memory address is same. So it will simply compare their memory address, and if it is same it will return true, otherwise it will return false. Whereas hashcode method will always return unique integer value as a hashcode of object, which is mostly integer representation of that object's memory address. So there is one contract between equals and hashcode method. If two objects are equals as per equals method, they should return same hashcode too. But if two objects are having same hashcode, it is not necessary that they are equal to. So this is contract between equals and hashcode method. So let's try to understand this in Java code. So this is student class with attribute ID, name and standard. And there is one constructor for student class, and there is getter setter method for student class. So while creating student class, requirement is that if two students are having same ID, same name and same standard, it means they are same student. So let's try to implement this requirement in a collection. I have created two objects of student class. Both are having equally same data. And I am trying to compare them by using equals method, and this equals method is coming from object class. And here I am creating student set, which is hash set. And ideally hash set should not allow to add duplicate values. And here I am adding both the student object. And here I am iterating that student set. So let's print their value. So now as you can see, it is giving me false. Even if there all the information is same, it is giving me false, that equals method, and it is allowing me to add same object inside a hash set. So let's create one more hash set, and I will add duplicate string value inside that. So this is another hash set where I am adding duplicate string value. So let's check their result also. Here ABC got printed only once, because equals and hashcode method is already overridden in string class, so that it will compare their actual value and it will return true if their value is same, and hashcode will always return same value if equals method is returning true. So similarly, we need to override equals and hashcode method in student class also. So let's try to do that. I'll do this for all the attribute because my requirement is if ID, name, standard all are same, then only the student is same. So here in equals method, it is checking if this object is not null, and if their ID is not same, return false. If their name is not same, return false. If their standard is not same, return false. If all are same, return true. And in hashcode method, it has written some logic to generate unique hashcode always. So let's check their result now. This time it didn't allow me to add same student object again. So here we saw why hashcode and equals methods are necessary to override. Hashcode and equal methods are used while fetching or putting element in hashmap or in hash table. So there also it is required. This we will see in next video in detail. With this we covered small but very important interview question. Please subscribe my channel Java Way if you want to know about more interview question every week, and please write in comment box if you want me to cover any specific interview question or you have any suggestion or comment for me. Thanks for watching. See you in next video. Hi everyone. Welcome to Java Way, where we will discuss about Java interview questions and their answers. In Java Wave channel, I used to come up with new interview question every week, and let me know if you want me to cover any specific interview question in comment box. So I am Gayatri, and today's interview question is how hashmap works internally, which is very important interview question for 3 to 6 years of Java developer. So let's try to understand basic feature of hashmap class. Hashmap implements map interface. It stores key and value pairs. It is not synchronized data structure, and it can be synchronized by using collections.synchronized map method. Put method is used to add object in hash map, and get method is used to fetch object from a hash map. Different type of object can be stored in a hash map if we are not using generate concept in our code. One null object as key and unlimited number of null object as value can be stored in a hash map. So now let's try to understand how hash map works internally while putting any element in a hash map and while fetching any element from a hash map. So here we have a hash map, number of goals, which stores number of goals for all the countries in a football match. And again I am fetching number of goal for few of the countries. So let's try to understand how it will store value while putting element and how it will again fetch values while getting element from a hash map. Hash map will store values inside a table kind of structure, or we can say inside an array object like in this way, and it has default size 16. So we have index from 0 to 15, and each row will be known as a bucket. So when put method is getting called, it will first calculate hash code of this key. Assume I am getting hash code of this key as 567. So there is again some logic written which will take input as a hash code, and it will give me index out of 0 to 15 to store this value. Assume I am getting index value as 9. So it will be stored at 9th place in this way. So at 9th place, it will be stored in the kind of linked list. So this is one of the node of a linked list which has key value, their hash code and actual value. For Russia also, it will first calculate their index value. Assume I am getting index value as 13. It will be stored at 13th place inside a linked list. So there is possibility that two key can return a same index value. So assume I am getting index value 13 for Italy also. So it will be stored as next node at
13th bucket in this way, and previous node will start pointing to next node, which is default behavior of LinkedList. So similarly, next value will also be get stored. Like Germany, it is giving me index value at 5, so it got stored at 5th bucket. Inland got stored at first bucket. Brazil again got index value as 9, so it got stored in next node of 9th bucket, and first one is started pointing to second one. And there is one element which has null key value. So by default, null key value will be stored at 0th index. So since there is only one null value allowed, so there will be no other element at 0th index. So this is how it will work in case of put element. So let's see how it will work when we will get element from this hash map. So while getting element also, it will first calculate hash code of this key and then again index for that key. So it will get value 9 for this one, and then it will compare their hash code and then their actual key value. And if both are matching, it will return their value. Similarly for inland also, it will first compare their hash code and then key, and if both are matching, it will return their value. Now Brazil will again return index value as 9. So it will first compare with this first node, and if their hash code is not matching, it will go to next node, and then it will compare their hash code, and if it is matching, it compare their actual key also, and if it is matching, it will return their values. So in this way, hash map will work while getting element and while fetching element. So let's try to understand few more facts about hash map. Default size of a hash map is 16 with load factor 0.75. So 16 into 0.75 is 12, which means once it reached at 12th position, it will increase its size on the basis of below formula. So formula is size will be 2 raised to 4, that is 16, which is default size, and 16 into 0.75 is 12, and once it reached at 12th position, it will again increase its size. It will be 2 raised to 5, which is 36. So new hash map will be size of 36, and once it is reached at 27th index, it will again increase its size, which will be 2 raised to 6, and again new hash map will be of size 72, and similarly this formula will be followed. So like in array list, once the size is getting increased, it will create a new hash map, and older record will be copied into new hash map, and older hash map will be available for garbage collection. In Java 8, there are few new features introduced for hashmap. Out of that, these three static variables are there which got introduced in Java 8 for hashmap: tree i5 threshold, untree i5 threshold, and min tree i5 capacity. So what is tree i5 threshold? And default value for this is 8, and if a bucket contain more than 8 values, if more than 8 node present there, it should be converted into a binary tree. So there will be no linked list, and it will be converted into a binary tree format. And untree threshold, if again some values are getting removed from hash map and size of that bucket is less than 6, so again it will be reconverted into linked list. And min tree i5 capacity 64. This means minimum number of available bucket before a bucket should get transformed into a tree should be 64. There should be minimum 64 buckets, and then only this formula will be applied. Otherwise it will first increase size of bucket, and then this issue occur, it will apply these two things. Other than this, there are many other method also which got introduced in Java 8, like compute if present, compute if absent. So Now here we saw how hashmap works internally in the case of get element and in the case of put element. So with this we completed very important interview question. Please subscribe my channel if you want to know about more interview question, and please write in comment box if you have any suggestion or any feedback for me, and write questions also if you want me to cover that question, and don't forget to subscribe my channel. Thanks for watching. See you in next video. Hi everyone. Welcome to Java Way channel, where we will discuss about Java interview questions and their answers. In Java Wave channel, I used to come with new interview question every week. So please let me know if you want me to cover any specific interview question, and if you have any suggestion or comments for me, and please subscribe my channel also. So today's interview question, or we can say today's discussion topic, is hash set, linked hash set, and tree set in relation framework. There are many questions on these three relations which can be asked in interview. So let's discuss about them. Hash set. Hash set extend abstract set class and implements set, clonable, and serializable interface. It is not synchronized but can be synchronized by using collection.synchronize set method. And as it implements set interface, it will not maintain insertion order and it will not allow to add duplicate values. Hash set internally create hashmap. So let's check how it works internally. In my last tutorial, I have covered how hashmap works internally. So first we need to understand how hashmap works internally. So I will suggest, please check my video how hashmap works internally. For that I have already given link in description. So here is one set, and in this set I am adding three objects, and value of first and third object is same. So as I said, hash set will create one hash map to store these value, and it will be in key value pair only. So it will first find out hash code of these value, and on the basis of that it will calculate index to store that value, and value which is added inside set, it will be stored as key. Here duplicate value will not be stored, so it will fulfill requirement of a set and duplicate value will not be stored. And in place of value it will store a constant present. Similarly for second value also it will calculate hash code, and on the basis of that it will calculate their index to store, and it will store actual value as a key, and in value of hash map it will store constant present. In third place I am adding same object. So since hash map will not allow duplicate key, so it cannot be added. It will not give any exception at compile type, and at runtime it will not give any exception, but value will not be added. Similarly for remove also, on the basis of key it will first calculate hash code and their index, and once it will get that it will remove that whole row. In this code we can see there is one hash set created, and I am adding value 1 to 7, and I am printing their value. So let's check their result. So all the values got printed, but there is no insertion order maintained. So as we can see, all values are printed, but there is no insertion order maintained. These are getting printed in random order and they are not sorted also. So this is feature of hash set. This will not maintain insertion order and it will not be sorted also. So let's check another collection. Linked hash set. It extends hash set class and implement set, clonable, and serializable interface. It is not synchronized but can be synchronized via using collection.synchronize set method. As it implements set interface, it will not allow to add duplicate value, but it will maintain insertion order. So this is something different which was not there in hash set. And to achieve these, linked hash set internally create linked hash map. So this is one linked hash set, and I am adding four objects to this linked hash set. Out of that, first and fourth one is same. So as I said, linked hash set will internally use linked hash map. So it will also store value in a key value pair, and key will be actual value which we are adding in a set, and value will be present, that is constant. So while adding these value inside bucket of hash map, it will store two more values, linked hashmap dot entry head and linked hashmap dot entry tail. Both will be transient variable. So inside bucket of hashmap, the value will be stored like this way. Assume I am getting index 1 for this ABC and hash code of ABC is 567. So it will first store hash code, actual value of key and actual value of value, and this will store next node's memory address. With this, head and tail value will also be stored, which will give idea of insertion order, the value which was added before this node and the value which was added after this node. So in this way, linked hash set will maintain insertion order. So here also let's change it to linked hash set and check result. So now we can see all the objects are printed in the way it was inserted inside set. So linked hash set maintain insertion order. So let's check other collection object also. So last one is tree set. It also extends abstract set class and implements navigable set, clonable and serializable interface. Navigable set extends sorted set interface and sorted set interface extends set interface. So tree set also extend set interface only indirectly, and it is not synchronized but can be synchronized via using collection.synchronize set method. And as it implements set interface, it will not maintain insertion order and it will not allow duplicates value, but it keep object in default sorted order, which was not the case in hash set and linked hash set. To achieve this, tree set internally creates tree map, and in tree map comparable interface is implemented to store all the object in default sorting order. So that is the reason tree set also store object in default sorting order. So let's check here also, and I will change this to tree set, tree set, and let's check the result. Now we can see all the values are in default sorted order. In this case, it is alphabetical order. So this is the difference between hash set, tree set, and linked hash set. Hash set will not maintain insertion order, not it will not be in sorted order, whereas linked hash set will maintain insertion order but it will not be in sorted order, and tree map will not maintain insertion order but it will be in sorted order. With this, we covered very important interview question. Please write in comment box if you have any suggestion or feedback for me, and don't forget to subscribe my channel. Thanks for watching. See you in next video. Hi everyone, welcome to Java Way, where we will discuss about Java interview questions and their answers. I used to come with new interview question every week, and if you want me to create video for any specific interview question, please let me know. Write in comment box. I will try to prepare video for that. And please subscribe my channel Java Way if you want to know new interview question every week. So I am Gayatri, and today's interview question is one of the most important interview question for collection framework for core Java also. Difference between comparable and comparator interface. So as name suggests, comparable and comparator both interface provide way of sorting to a group of object or a collection. Comparable interface is present in the java.land package, whereas comparator is present in java.util package. Comparable interface can be used to achieve single way of sorting like ascending or descending sorting order for numeric collection or alphabetical sorting order for string object collection. Whereas comparator interface can be used to achieve multiple way of sorting. Sorting without using comparable and comparator. So we can sort object
of collection without using comparable and comparator also. For that, there is method in arrays class, sort method, that is static method, that which can be used to sort arrays. And there is another sort method in class collection which can be used to sort any other collection other than arrays. So let's try to understand this in Java code. So in this Java code, first we will try to understand sorting without using comparable and comparator interface, which can be done by using arrays.sort method and collection.sort method. So there is one string array countries in FIFA 18 which has name of the countries which are participating in FIFA 18. As you all know, now FIFA 18 is going on. And I want to sort them on the basis of their name in alphabetical order. So for that I have written arrays.sort method and I am passing country's name as an input argument. Similarly, if I want to sort them on the basis of their ranking, that can also be done in arrays.sort method. And if country information is not present in arrays and it is there in a list format or any other collection object, so to sort them, collection.sort method can be used. So there are three different way to sort a country information. So let's try to run them. So first one is giving me alphabetical sorting of country's name. Second one is giving me their ranking is sorted from 1 to 5. Third one is again giving me name of the country sorted in alphabetical order. So these are the basic way of sorting without using comparable and comparator. So where is use comes for comparator and comparable. So let's try to understand that also. If I want to create a country information at bigger level, so I have created one class which has country ranking, country name, continent name, and country language also. And there is getter and setter method for that. And finally, I have implemented two string method also to print their information. In this class, I have created 6 countries and I have provided their information like their ranking, their name, their continent name, and their language. So these rankings are before FIFA 18, so don't get confused. And I will use arrays.sort method here to sort them. Let's see. This time it is giving me error. An error is class task exception countries cannot be cast into java.lang comparable. So to compare any this type of object which has multiple information, comparable interface need to be implemented. So here comes use of comparable. So let's try to understand that also. So comparable interface. Comparable interface has only one method declaration in it, and that is compare to. Comparable interface need to be implemented by the class and comparison logic should be written by overriding compare to method. Like a dot compare to b, where a and b is getting compared. Compare to method should be overridden to get negative number if a is less than b, 0 a and b both are equal, and positive number if a is greater than b. Compare to method can throw two type of exception. One is null pointer exception if a or b are null. Class task exception if a and b are objects from different class. So it cannot be compared, it should be from same class, and if we are using generics this exception will not come. So let's check Java code for comparable interface also. So to use comparable interface, our main object class countries needs to implement comparable interface. So let's try to do that. And it need to override compare to method. So here I am sorting countries on the basis of their ranking. I have written code for that in compare to method. And if comparable interface is implemented, no need to change anything here and it will automatically call this compare to method. So let's check the result. Now there is no error and all the country information are sorted on the basis of their country ranking. And if requirement is to sort them on the basis of their name, compare to method can be written in that way also. Here they are getting sorted on the basis of their name, and let's check their result again. So now countries information are sorted on the basis of their country name in alphabetical order. So this was comparable interface where we can sort any object in single way of sorting. And what if there is requirement to sort them in multiple way? Like someone wants to sort these countries information on the basis of their ranking, someone wants to sort these countries information on the basis of their language or their continent name or their country name. So there should be a class which can give me all. By using comparable, we can sort them in a single way. So here comes use of comparator. Let's check that also. So comparator interface. In comparator interface, only two methods are declared. First one is compare and second one is equals. Comparator interface need to be implemented by sorter class, and comparison logic should be written by overriding compare method. So there is no need to change original country class. We can write comparison logic in a different class which can be used for only sorting. Compare method should be overridden to get negative value if a is less than b, 0 if a and b both are equal, and positive if a is greater than b, same as compare to method from comparable interface. And same as compare to method, compare method can also throw two type of exception: null pointer exception if a or b are null, class task exception if a and b are objects of different class, and this error will not come if we are using generates. So let's try to understand comparator interface in Java code also. So here I have written one class compare by country rank class by implementing comparator interface. This is only for to sort countries on the basis of their ranking. And there is another class is written which will sort country on the basis of their name. So we can use both the way. Let me comment previous one where I am using comparable interface, and we will see use of comparator interface. To use comparator interface, I need to provide country list and new object of compare by country rank, and if I want to compare them on the basis of their ranking, and compare by country name if I want to compare them on the basis of their name. So there is two different way of sorting which we can use at same time. Let me run this code. So as you can see here, it is getting sorted on the basis of their ranking, and here it is getting sorted in alphabetical order of their country name. So similarly we can implement multiple way of sorting. So here comes use of comparator interface. So finally now we know about comparable and comparator interface. So let's check their differences also, which was our original interview question. Comparable interface can be used to achieve single way of sorting, whereas comparator interface can be used to achieve multiple way of sorting. Comparable interface is present in java.land package, whereas comparator interface is present in java.util package. Compare to method need to be overridden to implement sorting logic in the case of comparable interface, and compare method need to be overridden to implement sorting logic in case of comparator interface. Original class need to modify to implement comparable interface. As we saw in our example, country class need to be modified. Original class need not to modify to implement comparator interface, and we can write sorting logic in a separate class. Calling method will be arrays.sort with arrays as an input argument in the case of arrays, and collection.sort with collection object as an input argument to call compare to method from comparable interface. In case of compare method from comparator interface, calling method will be arrays.sort. Arrays will be first input argument, and we need to provide comparator class object.
Similarly, for collection.sort, collection object, and we need to provide object of comparator class. So these are 5 main differences between comparable and comparator interface. So with this, we covered one of the most important interview question of core Java, difference between comparable and comparator interface. As I said earlier, please write in comment box if you want me to create video for any other interview question, and please subscribe my channel Java Wave to know about more interview question every week. Thanks for watching. See you in next video. Hi everyone. Very warm welcome to Java Wave, where we will discuss about Java interview questions and their answers. And today's interview topic is Introduction to Collection Framework. Very important and very famous interview topic for all level of Java programmer. First of all, let's try to understand what is collection framework in Java. Collection framework is a collection of interfaces and classes and algorithm which is used to handle group of objects like a single unit. Collection framework is introduced in Java 1.2. Before Java 1.2, there were few classes like vector, stat, array, hash table, which was used to work with group of objects. Interfaces and classes of collection framework are used in almost all Java programs, and they are part of java.util package. So let's start with interfaces and classes of collection framework. Collection interface. Collection interface is root interface of collection framework, and since it is root interface of collection framework, it has most common method declared which every collection class need to implement if it is extending collection interface. And methods are like size, iterator, contain, add, remove, clear, toArray, is empty. These are some basic common method which is available in collection interface. Iterator interface. Iterator interface is used to iterate over in collection, and it allows to remove element while iterating over a collection. And it has only three methods: hash next to find out if any next value is available, next to get next value, and remove particular index value. Another interface is set interface, which extends collection interface. Duplicates objects are not allowed in set interface. While adding duplicate objects, it will not throw any exception, but it will not add them also. Set is an unordered collection and it does not maintain insertion order. Means the way objects are inserted, it is not necessarily the same way it can be fetched also. One null value is allowed in set. Random access is not possible for set. Iterator or for each loop can be used to iterate over a set in one direction. Hash set, tree set, sorted set, and linked hash set are few commonly used classes which are implementing set interface. Another interface is list interface, which also extend collection interface, and duplicates are allowed in list interface. It is an ordered collection and it maintain insertion order. Means the way objects or elements are inserted in a list interface, it can be fetched in same order. List provide method to add, remove, replace object at specific index. So random access is also possible in the case of list. Iterator or for each loop can be used to iterate over a list in one direction, and list iterator can be used for bidirectional iteration over a list. So this is extra feature for list. By using list iterator, bidirectional iteration is possible for list. ArrayList, LinkedList, copy on write ArrayList are few commonly used classes which implements list interface. Another main interface of collection framework is map interface. Map interface does not extend collection interface, but it is part of collection framework, and it maintains key and value pair. There will be one unique key for all the values. That's the reason duplicates are not allowed for key. Map interface provides method to put, remove, and get value by providing key. Hashmap, tree map, and linked hashmap are some commonly used classes which implement map interface. So as we saw, all main interface of relation interface: iterator,
set, list and map interface. Collection framework also provides some synchronized wrapper to provide thread safety. Or in other words, we can say it also provide a wrapper to provide thread safe collection object. So there are 6 static method in collection framework which we can use to get synchronized collection object, like synchronized collection, synchronized set, synchronized list, synchronized map, synchronized sorted set and synchronized sorted map. Similarly, there are 6 static methods to get unmodifiable collection object. In other words, we can say to get immutable collection object. So unmodifiable collection, unmodifiable set, unmodifiable list, unmodifiable map, unmodifiable sorted set and unmodifiable sorted map. Other than these, there are few algorithms are also available in collection framework, or we can say few set of static methods are available in collection classes, like sort. This will sort collection in natural order or by using a comparator. Shuffle. This will shuffle collection and destroy their natural ordering. Composition. This will test composition between two collection objects. And min and max method. This will again get min and max value of collection either in a natural way or by using comparator. So with this we covered basic information about collection framework. Since collection framework is very vast topic, I will try to cover few more interview questions of collection framework in my next video tutorials. Please write in comment box if you have any suggestion or question for me. And please subscribe my channel Java Wave to know about more interview question every week. Thanks for watching. See you in next video.
Hi everyone, welcome to Java Wave, where we will discuss about Java interview questions and their answers. I am Gayatri and today's interview topic is using generates in collection framework, which is very important interview question for all level of Java programmer. So let's start. So what is generates and why it is required in collection framework? So generate was introduced in Java 5 and generate provide type safety so that only single type of object can be added into a collection. And after using generate, typecasting is not required. So why we are using generates in collection framework? So that only one type of object can be added into a collection, and if it is one type of object then there will be no typecasting required. So let's try to understand these topic in Java code also. So in this Java code, I have created one array list, simple array list, and where I am adding two string value ABC and xyz, and third place I am adding a boolean value. And in this for loop, I am trying to iterate over this simple array list and I am printing their values also. But while iterating, I need to typecast the values into string value because my assumption is that all the values will be string only in simple array list. So I am typecasting them into string and I am printing their values. So let's run this code. It has given me exception. Java.len class cast exception. Java.len boolean cannot be cast into Java.len string, and it is giving me exception at this line where I am trying to typecast a boolean value into a string value, and this error is coming at runtime, not at compile time. Type of situation and getting error at runtime, we will add generates and let's see the difference. Now I am telling this array list accept only string type of object. So now it is giving me error while adding a boolean object, and this error is coming at compile time, and handling any error at compile time is always better. So let's remove this line, and this typecasting is also not required because it is fits that all object of simple array list will be string only. So let's try to run this. Now it is not giving any error. So this is basic use of generates, where we can make sure only single type of object will be present in my collection, and that need not to be typecast again while fetching the argument. So now we saw basic example of generics in collection framework where we took example of array list. So there is one wildcard also available in generic, which is question mark. Question mark is considered as wildcard in generics. So if I am keeping question mark in this way, so it can replace any class, and so it is unbound generic way. Similarly, if I am writing in this way question mark super any class name, it means any class which is parent of class T, and question mark will replace parent class of class T. So it is lower bound. And if it is in this way question mark extend T, it means any class which is child class of T, and question mark will replace child class of T, so it is upper bound. So let's try to understand these three uses of wildcard in Java code also. So in this example, I will try to use wildcards. Wildcards are there to increase or decrease the number of classes which can be defined in the generates. So like this one, I have created one object list where I am adding object ABC, XYZ and 123. 123 is an integer object, whereas ABC and XYZ is an string object. So I want to create a list where I can add integer as well as string also. So to print this list, I have created one method where I have given generates way as question mark, so that any object list can come here and it can be printed also. Now there is in second example, I have created one string list and I am adding three string values. But I want to restrict, this method can be used to print only string or its child classes. So I have written in this way question mark super string buffer. So string buffer is child class of string class, so it can be printed here. And it is lower bound because string is parent class and it is getting converted into a child class, that string buffer, so it is lower bound. Now there is three more list: integer list, float list, double list, and I want to write one common method to print all of them. As we all know, number is parent class of integer, float and double also. So to print this list, I have written one common method where we can use question mark extend number. So all the now classes which are extending number can be printed here. So let's try to run this example. I can see all the lists are getting printed. So this example shows use of wildcard. I can use in unbound way, it is in lower bound way, and it is in upper bound way. Another topic for generates is dealing with generate type T. So what is dealing with generate type T? This we can use while creating our custom collection where we want to use custom generates. Generate types will help to create custom generate types. With the help of that Java method which can return multiple type of object can be created. So let's try to understand this also in Java code. So to explain this topic, I have created one class custom generate type, and generate type I have given as T. ArrayList instance variable is here with generate type T again. There is two methods, add data and remove data, to add and remove object from ArrayList. And this method is to print test data as a string, and this method is to print test data as int. So basically, I want to create one class which can handle string as well as int value also. So let's try to use this class. So in this class, this block is to handle string value and this block is to handle integer value. So same class can handle string value also and integer value also. As I have provided t in here,
So I can put string, integer or any other object also. So in this way we can create our custom generate types also. So as we can see, it is printing string as well as integer values. With this we covered this topic, and in our few next videos we will use generate in collection. And if you have any suggestion or question, please write in comment box. Thanks for watching. See you in next video.